Hello everybody. This is a review of binomial distributions. I'll try to cover everything in this one quick lesson here. All right, so binomial distributions, remember in order to apply the binomial model, these events must be, or these situations must be Bernoulli trials, and they have to meet three conditions to be that. They have to have only two possible outcomes, a constant probability of success, and the trials have to be independent. In this particular case, we have green-eyed people. 2% of the world's population, it says, are green-eyed people. So the constant probability of successes, or two possible outcomes, are either green-eyed or not, what we're interested in. And then every time I check a randomly chosen person, I have a 2% chance that they'll have green eyes. Okay, and independent, the eye color of one person doesn't affect the eye color of another person. Okay, so they satisfy the Bernoulli trials, and we're ready to start. Okay, I have a... And it says the sample randomly chosen, and that's important. All right, I have 150 people in my randomly chosen sample. All right, what's the probability that I get, or excuse me, I guess here it is, what is the chance of getting 5% with green eyes? All right, so first of all, I can't put a percent into my calculator. Remember that we actually checked 150 people, and so there's an exact amount that had green eyes and some didn't. So I'm going to do 0.05 times 150 on my calculator. That equals 7.5. That means really there were 8 people that had green eyes, and they rounded it down and said 5%, which is really the inaccurate part. Okay? So 8 is what I'm really talking about. Okay, this is the number of people with green eyes that X represents. The probability that it equals 8. Okay, if you remember this down here. Okay, this is the combination of, out of 150, we're choosing 8. Okay, and there's many ways for that to happen. Okay, and this represents the number of ways for that to happen. Up here, what we have, this is the possibility of green eyes. Notice we have 8 of those, so there's 8 of those. Okay, and then 98% do not, and out of 150, there's 142 that we had of those. Okay, now those 8 people could have happened with green eyes in any different situation. There's lots of different ways it could happen. This is how many ways that could happen. Okay, and this is literally the math that your calculator does and that you could do, okay? And we're going to go ahead and do it on our calculator, and it's going to be binomial PDF because I'm looking for an exact value that it equals 8 people only. All right? So binomial PDF, put in my trials, 150. P-value of success is 0.02. And the X value I'm interested in 8. Notice I'm on PDF though. It's only going to calculate the probability of getting 8 of them. 0.0076 is my answer for that one. Okay, moving on. The probability I get 7 or less green-eyed people. Okay, anytime I have a group, I recommend putting up 7 and the number before and after. Okay, and we want 7 or less, so we want 7 or less. Okay, and if I put 7 in my calculator, that's what it does. It calculates the probability of getting 7 green-eyed people, or 6, or 5, or 4, or 3, or 2, or 1, or no green-eyed people in my sample. And it's going to add all those up. Okay? So for us, what I want to translate that into is less than or equal to. That's what my calculator does always. Okay, so the probability X is less than or equal to 7, again, which is what I want. Okay, would be the probability of getting 0 of them. In this case, again, I have no green-eyed people, which means I have 150 with green eyes. Okay, over here I'm choosing 1, which means I had 1 green-eyed person and 149 that were not green-eyed, and so on. That's my first 2 up to the last one, and the last one would be choosing 8. Okay, if I got 8 green-eyed people, I would have 8.02s and 142 that are not green eyes. All right, and then again, that just translates into binomial CDF. Notice it's CDF now. And I'm putting in the same thing. I'm putting in 7 there. Okay, but now it represents 7 and everything before it because I'm on CDF. Second distribution, go to binomial CDF. Trials again is 150. I have 150 people in it. P-value is 0.02, and my X value is 7. Okay, and my answer is going to be 0.9890. Okay? And if you looked up here, we put, oh, we had 8 there. It was different. I thought it was the same. All right, anyways, let's come on to our next one. Less than 8. Less than 8 means this. Okay, well now it's going to be less than or equal to 7 is what I want to put in my calculator. All right, I'm going to skip the work right now just to speed up for our lesson. This will end up being binomial CDF. 150 is our number of trials, 0.02 probability of success, and the number that I'm looking for here is going to be 7 this time. Second distribution, binomial CDF, same values. I have 7. I'm curious why that. I think I might have done it. Let me look at this last one here. Less than or equal to 7. Oh, less than 8. That's equal to less than or equal to 7, which is the problem we just did. If you'll notice, that is 0.9890. Okay? All right. So less than 8 translates to less than or equal to 7. Again, that's the last problem we just did there. Okay, here we go. At least 8 green-eyed people. Now I want 8 or more. Okay, and if I said more than 8, it would be 9 or more. Okay, my calculator doesn't do that. My calculator only figures out something to the left here. Okay, so again, greater or equal to 8, I want to translate it to, watch what it ends up being, is 1 minus the probability that x is less than or equal to 7 again. Okay? And that'll give us, this is going to do all of this, and 1 minus that will leave me with the green area, which is what I'm looking for. All right, on my calculator, I do 1 minus binomial CDF. Again, 150 is my number of trials, it'll say, and my p-value of success is 0.02, and we're going to put in 7 again. Okay, but this time it's 1 minus that. All right, so I'm going to type literally 1 minus, and now hit my binomial CDF. Second distribution. Okay, choose binomial CDF. Or it's already in there. Go down and paste it. And now it's going to actually do 1 minus the whole thing. And that gives me my answer, which is 0.0110. All right. And I think that's our last one I have there. Yeah, that is it. All right, I hope that helps you guys. Thank you.